Okay, 6 years. I just want to go back over here. Exercise 17. These are the solutions that I've just posted up online. The inferential statistics. Okay, the first couple of questions here, I hadn't given you these to do, but I just want to go through them with you on page 451. Now, the first thing you're asked there in question 1, which of the following distributions are normally or approximately normally distributed? Draw each frequency distribution roughly. Okay, so you just thrown a line more or less over this here. Now you can see that's not normal because normal is your bell shape, right? This is normal. That type of thing. So it's not normal. It's the tail is going off here to the right. So we say that that's positively skewed. Okay. Now, the second one, the stem and leaf. So if you throw your, draw a rough graph around it, a curve around it, what shape would the curve have? Well, you see there that it looks like it's a normal distribution or approximately normal, right? Okay, that's the second one. That's B. C then. It's stem and leaf. Too far. This is C. It's a stem and leaf. And again, this is a stem and leaf. It's not normal or approximately normal. It's more positively skewed. Right? Because you can see that if it was normal, it should be ending around here. It's not. There's a tail going out. So if you turn your copy around, you'll see that, it's extending out here. So therefore, it's not normal. The tail is going out to the right if you flip your copy around, and so it's positively skewed. Okay, question 2. Right, with question 2 here, we're asked, comment on the shape of the distribution below under the headings unimodal, symmetric, or skewness. Now, unimodal, symmetric, and skewness. So it has one mode, right? So it's unimodal, right? It's not symmetrical, right? It's not this shape. This is symmetrical. It is skewed, and the skewed goes to the left here. So therefore we say the tail is to the left. It's negatively skewed. Question 3. Right, in question 3, copy and complete the following frequency distribution. Comment on their shapes, mark the position of the mode and the approximate position of the median and the mean. Right, so if you are to copy the following frequency distribution and comment on their shapes. Okay, so you have your variables there in your first one. You start there at 10, 11, 12, 13, 14. 10, there's no 10. 11 is there once. There's 1 dot at 12. There's 3 at 14 and so on. You get your f of x. You multiply your frequency by your variable all the way down along. And you get the sum of your frequencies, 126. The sum of the fx is 126. The sum of your frequencies is 9. So how do you get the mean? It's sigma sum of fx divided by the sum of the frequencies. Remember, that's your mean, right? So your mean is 14, right? It's 126 divided by 9, so you get 14. What's the mode there? The one with the greatest frequency is 14, so your mode is 14. What's your median? Well, you have how many pieces of information? You have 9. Half of 9 is 4.5, rounded up. So the fifth dot, 1, 2, 3, the fifth dot occurs in here. So therefore, your median is also 14. Right? So your mode, your mean, your median, they're all in the middle of the graph, which of course, if you were to draw your line around this again, you can see that it would be symmetrical. Right? So it's symmetrical. So your mode, your mean, your median, they're all in the middle. Remember we said that a symmetrical or bell-shaped curve, the mode will be equal to the mean, will be equal to the median. They'll be all there in the middle. Okay, now let's look at B. Right, so that's it there. They're all there in the middle. Okay, let's look at B and what have we got here. Well, you can even see here if you were to put this in here. Right, you can see that it's skewed, right? So you know straight away that it is not what? It is not symmetrical or bell-shaped. Again, we can write out our frequency distribution here. We've 0, we've 5, 10, 15, 20, all of these. Count the number of dots beside them, multiply the frequency by the variable f times x all the way down along, and you get the sum of the frequencies is 273. Or 275, the sum of the fx's rather is 275, the sum of the frequencies is 11. So I divide 275 by 11 and I get 25. So 25 will be my mean. What's my median? How many pieces of information do I have? I have 11. Half of 11 is 5.5, rounded up. The sixth dot, where does that occur? 1, 2, 3, 4, 5. It occurs in here. So therefore I say my median is what? It's 30. It's in the sixth dot is in here. So the median therefore is 30. And how do I get the mode? Well, the mode is also 30. Right? So you can see there that the mean is less than the median and the mode. So if I was to draw it in then to the diagram, I will put in, that's my mean, x bar, and this line here will be both my mode and my median. They'll both be the same. Okay? Mode and median. So you just write mode equals median. Okay? And you can see it's negatively skewed, and in a negatively skewed graph, the mean is always less than the mean, is less than the median. Right, let's look at C. It's just drawn out there for you. Let's look at C again. What have I got here? See, it's going to be positively skewed this time, and I can tell straight away, there's my mode, it's at 35. So where's my median? Well, how many pieces of information do I have? I've 1 and 2 is 3 and 2, 5 and 2, 7, 8, 9, 10, 11. So half of 11 is 5.5. So where's the sixth dot? 1, 2, 3, 4, 5, 6. It occurs in here. So this here is going to be both my mode and my median. Mode and the median is going to be there at the same thing. MEDM is all I'm going to write down now here for median. Okay, so the mode and the median are there. What's the mean going to be? Again, write out all my variables, my frequency, get my fx, it's 415, divide that by 11, and I get 37.7. So it's going to be out here. Right? So that's going to be my mean. Okay? So you have to work it out. There's no way of, you're not going to be guessing it. So you're going to be working it out. Okay, so I hope you understand that. That's questions 1, 2, 3. Now, the next one then, part D. Right, part D. What are we asked in part D? You're given this graph, right? It's a normal distribution, right? The frequency, that's D here, right? And again, what am I asked to do? Because it's a normal distribution, my mean, my mode, and my median will always all be here in the middle, right? It's going from 0 to 100, so there at 50, my mode, my median, and my mean, because it's approximately normal, right? Now, what about E? Right, well, I can see here, again, sorry now, put that out. I just want to get the shape. So you can see that it's negatively skewed is what I'm trying to show you there, right? The tail is going back. Most of the values are over here, right? The lower values are here at the beginning, and then they get higher, right? So it's negatively skewed. The tail goes to the left. Remember, it's negatively skewed. So again, if I want to find the position of the mean, the mode, and the median, right? Well, what do I do? Again, how do I get the mean? Well, I have to write out my distribution table here. Right, my 0 to 10, I work it all out and I get the sum of the fx's is 6870, sum of the frequencies is 90, I divide them, I get 76.3, that's my mean. Right, that's my mean. How do I get my mode? Right, well, I look at the tallest one here, and that's the block 90 to 100, so I take the middle between 90 and 100 is 95, so that's my mode. How do I get my median? Right, well, I have how many pieces of information? I have 90, my total frequency is 90, half of 90 is 45, so where would the 45th and the 46th values lie? Right, so I have, right, I count up along here. I can go back actually to the table, it'll be easier. Remember, I'm looking for the 45th and the 46th, right? So that's 45. So in the 40 to 50 interval, so that's 5, 15, 25, 35, 40 to 50, and 50 to 60. So I have to go back to look at the frequency. Where's the 45th and the 46th going to lie? I looked at the wrong one. This is my frequency 1 and 2, 3 and 3, 6 and 4 is 10, 5 is 15, 21, 31, 32, 42, 44. So that's 44 there. Right? Now, if I add in 14, I get 56. So up as far as here is, what did I say, 23, 29, 34, 38, 41, and 4. I get 45. That's right. Just double check that again. 1 and 2, 3 and 3, 6 and 4, 10, 15, 21, 31. 2 is 33, 43 and 2, that's 45. Remember, I have to take the 45th and the 46th value, and the 46th value occurs between 80 and 90. Right? So, So 45.5 or the 46th value, it will occur in here in 80 to 90. And so it's going to occur in this class interval. So it'll be very close to 80 actually. Right, it'll be quite close to 80, closer to 80 than 90. Okay, so that's going to be my median. My mean is less than that, and my mode is greater than it. So I fill them in. Okay, now it's hard to do this here. So you see there, that's your median, right, between 80 and 90. Your mode, right, this was your mode here, and your mean was 70 something. So your mean, then your median, and your mode. Right, so you actually have to work them out. Now let's look at question 4. That was the next question I'd given you there for homework. Question 4. Going back again to the empirical rule, right, we know that the mean minus 1 standard deviation and the mean plus 1 standard deviation, where this mu here is the mean. This is minus 1 standard deviation, this is plus 1 standard deviation, and remember this is 68% of this total area is within 1 standard deviation of the mean. So the 1 standard deviation of the mean, that takes, as I said, into account 68%. So from here to here is 68%, 34% above the mean, 34 below, because I divide 68 by 2. So I explained all of that the last day. So let's look then at question 4. Light bulbs have a mean lifetime, so X bar is equal to 850 hours, with a standard deviation of 70 hours. What percentage lasts between 850 and 920 hours? Well, 850 is your mean, and 920 is your mean plus 1 standard deviation. So going back up to this here, I suggest that every time you're doing these, actually, the best thing to do is draw out a little a normal distribution. Right, put in down along here. This is your X bar. Right, and you have your 1 standard deviation above and 1 below, right? So that's 850. Remember now, this is your X bar, this is sigma. This is minus sigma. Your X bar, remember, is your 850. That's 850. Oh my God, it's so difficult to write this. Right, so that's going to be your 850. And this here is 850 plus 70, so that's going to be your 920. Now I want to know the percentage that lie between 850. So this percentage in here is what you want, what you're asked to get, right? So remember, the whole thing from there to there is 68%. So therefore this bit has to be half of that, which is 34. Now the next question was, what percentage lasts between 780 and 920? Well, 780 is 850 minus 70. So it's between it's between one standard deviation below and one above. So what percentage is all of that? Well, it's 68%. Longer than 990. Well, 990 is out here. And what's 990? 990, right? Plus or minus 990 will be your 95%. So remember, 95% divided by 2, right? 95%. Remember that again, all of this here is 50%. Right? 50%. Right? The whole thing is 100%. This part here is 50%. So 990 will last longer than 990 hours. So 990 would be 920 plus 70 is 990. So it's 2 standard deviations. So greater than or equal to 2 standard deviations above. So 2 standard deviations above and below is 95%. Right? So if I take 95% from 100, I get 5%. Now, half of that, then 2.5% is going to be greater, and 2.5% will be less. Okay, so the last part of that then is if a shop bought 2,000 of these bulbs, how many might burn out before 920 hours? Now, up as far as here, we said, is 920, right? Up as far as here. So all this much of them would burn out before 920 hours. So how many is that? Well, up to this dotted line here is 50%. Plus, remember, this is half. It's 1 standard deviation here. These 2 sections are 68. This bit here, go back to your diagram again, is 34. So 50 plus 34 is 84% would burn out before 920 hours, right? Because up to here, it's 84%, right? It's 50 plus this 34 is 84%. I get 84% of 2,000, and that's 1,680. Okay, question 5. Right, so question 5 was, in an agricultural science test, the mean is 50. So mu or x bar is 50. The standard deviation is 4. What percentage of the students scored between 42 and 62? So you have to work out what's 42. So take 42 from 50, that's a difference of 8. How many standard deviations is that? It's 2, right? And 62, what's the difference between 50 and 62? It's 12. That's 3 standard deviations, right? So it's between 2 standard deviations below. I'll try drawing this here again. Right. This is your mean, which is your x bar. And your x bar here is 50. Now, if this bit here is 1 standard deviation minus sigma, walk along, that'll be 2 standard deviations above, 2 below, and 3 standard deviations. Now again, what you were asked was between, so we've worked out that 42 is here. It's 2 standard deviations below, right? That's 42. Just going to put an X there and that. That's 42. And 62 is 3 standard deviations above. So what percentage of students lie in this bracket here? Well, we know between -2 standard deviations and +2 standard deviations is 95%. Right? We know that that's 95%, and we know between -3 below up to here is your 99.7%. 99.7. So the difference between 95 and 99.7 is 4.7%, right? 4.7%. But remember that 4.7 is divided between here and here. So I have to divide the difference, which is 4.7 by 2. And 4.7 divided by 2 is 2.35. So I have to add 2.35 to 95 because it's 95 plus this bit. And this bit here is 2.35. So I add 2.35 to 95 because it's between here and here. Because between -2 and +2 standard deviations is 95%. But between 2 standard deviations and 3 standard deviations above is 2.35% because it's just those above. So I have to add 95 to 2.35, so I get 97.35%. Okay, that's how they arrive at that answer there. Question 6. Right, sorry now. Right, so this is question 6 here. What was the question? That's the answer. A class survey shows that students watch an average of 23 hours of television per week with a standard deviation of 2 hours. What approximate percentage of students watch more than 25 hours per week? Okay. So again, you see, every time you need to do out your sorry now, it keeps moving on me. Right, you need to do out your curve again. Just do out your curve, put in what you know. This is your mean, and your mean again, X bar, and that's 23. Right, 1 standard deviation above and below. Well, the standard deviation is 2. Right, so that'll be 25. Now, the question was, what approximate percentage of students watch more than 25 hours per week? So this would be where 25 hours would be at. So what is that? Well, remember again that between these two values is 68%, right? That's 68%, right? So it's the numbers that's greater than this, right? So this is 68%. Between these two here is 68%. But this part here, remember, all of this is 50. This bit here is 34, so that's 84. So up to here in total is going to be 84%. I hope you understand that, because keep remembering this is 50%. It's just between these two here is 68%. But all the number less than that is that's 50%. Half of this, if this is 68, that bit is 34. That's 34, that's 34. So it's 50 plus 34 is 84. So up to less than 25 hours a week is 84%. So more than 25 hours a week is you take 84 from 100 and you get 16%, which as a decimal is 0.16. 16 over 100. Okay, so that's the approximate percentage of students who watch more than 25 hours per week. If a student is selected at random, what's the probability that he or she watches more than 25 hours per week? Well, it's 16%. So 16% as a decimal is 0.16. Okay, number 7. Right, let's look at question 7. On a normal distribution curve, 68% of the survival times of mice distributed symmetrically about the mean were between 8 and 14 days after being infected by a bacterium. Right, so 68%, you're told, lasted between 68%. Now it's 68%, so you've got to know that's one standard deviation above and one standard deviation below. So if the interval goes from 8 to 14, that's a gap of 6. Half of 6 is 3. So 8 plus 3 gives me 11. So therefore, I know that that's 50%, or my mean is there at 11. So the mean survival time, therefore, is 11 days. The standard deviation is between 11 and 14. So what's my standard deviation? What's the difference between 11 and 14? It's 3 days. Question 8. Right, now looking at question 8, the temperatures of a meteorology station during the month of February measured in degrees Celsius are shown in the following table. So there are all the different temperatures recorded for the month. Find the mean temperature and the standard deviation correct to one decimal place. So how do I find the mean? I have to add them all up. In number 8, I have to add them all up, right? And I have to divide by the number 1, 2, 3, 4, 5, 6. 6 by 4 is 24, 26, 28. So there was 29 days in that particular month of February, right? So I add them all up, I divide by 29, and I get the mean to be 9 degrees. Right, find the standard deviation. Will you use your xf d squared and f times d squared? You put it into your calculator, you get your standard deviation to be 2.6. Now, assuming approximately normal distribution, in other words, that it follows a normal distribution curve. So again, right? And again, my mean is in here, my x bar, and that's 9. Okay. And how you get your standard deviation works out to be 2.6. When you work out your standard deviation, you get 2.6. Assuming approximately normal distribution, find what range of temperatures centered on the mean in February will cover 95% of the time. Well, you've got to know that 95%, you know that 95% is plus or minus 2 standard deviations of the mean. So what's 9 minus 2 standard deviations? It's 9 minus twice 2.6, which is 5.2. And 9 minus 5.2 gives me 3.8. So between 3.8 and the other degree then is 9 plus 2 standard deviations, 9 plus 2 times 2.6, which is 5.2, and you get 14.2. So it'll go between 3.8 and 14.2, and that's how you'd write it. Right, it'd go 95% is within 2 standard deviations of the mean, right? And it'd be between 3.8 and 14.2. Right? Question 9 then. Right, so what does question 9 state? Let's go back to it here in the textbook. The length of human pregnancies from conception to birth varies according to an approximate normal distribution. Again, you draw out. Every time you get these, you draw out your own little diagram. Just draw a rough little curve because it makes it much easier for you. Right, so your mean there again is 265, you're told, and a standard deviation of 16. 265. Right, and a standard deviation of 16 days. In other words, it could be 16. So what you're saying there really is that 68% of births will be 265 minus 16 to 265 plus 16. So you're asked then, between what values on either side of the mean do the lengths of 95% of pregnancies fall? Well, 95% again is within 2 standard deviations of the mean. So it's the mean minus 2 standard deviations, 265 minus twice 16 minus 32 gives me 233. And 265 plus 32 gives me 297. So 95% of pregnancies will last between 233 days and 297 days. How short is the shortest? 2.35% of all pregnancies. So the 2.35% of all pregnancies. Right, so that's if we say 95%, so the other 5% are either 3 standard deviations below the mean. So what's 3 standard deviations below, between 3 standard deviations below and 3 above? That would be 5%. And half of 5%, sorry, okay, back to what we were doing here again. Right, so this is our 265. That's our minus 1 standard deviation, our minus 2, and our minus 3. Well, we know that plus or minus 2 standard deviations takes in 95% of the population. Plus or minus 3 standard deviations takes in 99.7%. So the difference between 2 and 3 standard deviations is 4.7%. Divide that by 2 and I get 2.35. So if I calculate 3 standard deviations below, what do I get? So it's 265 minus 3 times 16. So it's 265 minus 3 times 16, and that gives me 217. So the shortest length of time, the shortest of the 2.35% of pregnancies would be 217 days. The longest would be 265 plus 3 times 16. If you were asked that, 265 plus 3 multiplied by 16. So the longest would be 313 days. That's the longest of the 2.35% of pregnancies, but the shortest would be 217. Okay. Question 10, the last question here. Right, so question question 10. Okay, what was question 10 here in your textbook? The mean quantity of milk produced daily by a cow in a dairy herd. Again, draw out your normal distribution. Anytime you're getting questions on the empirical rule, you need to draw out your normal distribution. Draw out just your rough diagram and put in what you know. Again, this is your X bar. What are you told X bar is? It's 12 litres. So that's the mean. What's the standard deviation? It's 0.5 litres. So the mean quantity of milk produced daily by a cow in a dairy herd is 12 litres. Assuming normal distribution with a standard deviation of 0.5, what is the range of volumes of milk on either side of the mean produced by 99.7% of the herd? So remember, 99.7% of the herd is plus or minus 3 standard deviations. Right? So 12 minus 3 standard deviations to 12 plus 3 standard deviations. That should be plus. Right? So I get between 10.5 and 13.5 litres. So 99.7% of milk volumes lie between 10.5 and 13.5 litres. That should be plus there, okay? Right. Now, the next thing you're asked, what percentage of the herd produced between 11 litres and 12.5 litres? So I look at 11 litres and I look at 12 litres. The difference is 1 litre, that's 2 standard deviations below, and 12.5, 2 standard deviations below. So I'll mark it in, minus 2 standard deviations. That's 11 litres. And in the range between, what was it again, 11 and 12.5. Well, this is 1 standard deviation above. That's how you get 12.5. Okay. So up as far as this, you've got 50%. So how many, we want to know what we have in here. What's that? Now again, between 1 standard deviation above and below is 68. Between 2 standard deviations above and below is 95. But 95, remember, is divided evenly between what's below and what's above. So if I divide 95 by 2, I'll get 47.5%. So say this here is 2 standard deviations. So this accounts for 95%. Okay, that's 95%. Right? So, but I'm not including this part here. So I have to figure out what that is, what percentage that's worth. Right? So I know that between here and here, I've 95%. Right? Divided by 2 is 47.5. 47.5. And between here and here, this bit in here is 34%. Right? So what's this bit in here? It's going to be